Off this set of videos with some concluding remarks. So, first concluding remark just says that that we can prove all of our basic limit laws with epsilons and deltas. So I'm not going to go through this. If you take a look at the textbook in this page right here, this gives you a proof of the sum law rigorously with epsilons and deltas. And for each of our other basic limit laws, the constant multiple rule, the product rule, the quotient rule, stuff like that, you can prove each one of those using this epsilon delta definition. And everything else, section 2.4 in continuity, everything else we can make completely 100% rigorous using epsilons and deltas. That's something that you would do if you took a course like Math 311 here. We prove everything from scratch. The second thing that I want to do is just about the graphical interpretations of what we've been doing. So let's just have two function graphs here where we want to have one of them to be a continuous function where the limit exists, and one of them to be a function with a jump discontinuity. So C C. And let's just see how our definitions apply and don't apply. So for f of x here, we can show that the limit as x goes to c of f of x is equal to L if for any epsilon you choose here, so here is L plus epsilon and L minus epsilon, you can always find some delta here, C plus delta and C minus delta, so that if your x values are between C minus delta and C plus delta, the output values will be between L minus epsilon, L plus epsilon. So input gives you that output. On the other hand, there's no possible choice for a limit over here because we can't guarantee that if we pick our values of x really close to c, there's no way we can guarantee that we'll be really close to the limit. So let's call this value here L1. And I say, okay, I want to be within this much of L1. Well, guess what? No matter how small I pick delta, I'm going to be picking up output values up here. And those output values are on the y-axis over here. And so, L1 minus epsilon, L1 plus epsilon. If I go any positive amount to the right of C, I'm ending up here, I'm picking up those values, I'm outside of that L1 minus epsilon to L1 plus epsilon interval there. If I move L1 up here instead, I'd be running into the same problems on the other side. So here we see that one side of the limits are going to exist, but here's just a little picture demonstration, picture to remind you that here these pictures help underscore that these limits don't exist because we have a jump discontinuity. And with that, we are all done with Chapter 2.